When a jet lands on an aircraft carrier, it needs to brake radically, putting an enormous strain on everything, especially the ball bearings of the undercarriage.
We have developed a new layered concept for the Air Force. It can reduce localized temperature quickly. This means if the bearing becomes very hot in one area, a chemical reaction is triggered that reduces the temperature. With this, we hope to increase the lifespan of these bearings.
The Montan University in Leoben works with national and international companies on a regular basis.
The Montan University, and this is an eye-catching fact, has the highest third-party funding of all Austrian universities. We raise over half of our overall budget through third-party funding by working on industrial projects, in addition to the share we get from the government. We're the only university doing this in Austria.
Montan University is in excellent financial shape and always has the latest technical equipment available.
Montan University offers the most outstanding program in all of Austria. Naturally, we have a very high number of students because of that. But students also know that after finishing their studies here, a job offer is guaranteed. Generally, our students are headhunted by the industry before they finish their studies.
In the Material Innovation Center, a team of scientists is working on the development of smart coatings for a variety of uses.
By shooting single ions into the target, we are able to knock out individual atoms from the surface. We place the material and the tool that will be coated in the enclosure. So, single atoms are taken from the material and transported to the tool where they condense. Through this technology, we are able to create new characteristics such as extremely hard surfaces, almost as hard as a diamond. We are able to combine this with high ductility in layers just a few thousandths of a millimeter thick.
Some surfaces are very ductile, others increase their hardness through use. The technicians in Leoben develop special mixtures for individual needs and build the layers atom by atom. They are developing materials that use less grease, and maybe, in the future, they will be able to completely eliminate the need for it.
Here we added vanadium. What does the vanadium do? It comes to the surface at high temperature and creates a vanadium oxide film by reacting with the oxygen in the air around it. This means there's a liquid film on the surface of the object, lubricating it.
Very expensive tools are coated with a material that changes color at a certain temperature.
With this technology, the manufacturer can prove that a user did not follow the given temperature guidelines. This is important in damage claims.
The balancing act between basic research and research for industrial projects works very well in Leoben. One delivers the ideas for the other.
Without the basic research, one could lose the connection to new ideas, which in turn are interesting for the industry. Equally important is not to lose focus on what the industry needs. Clearly, sometimes our industry partners insist that we hand over all the research and results to them, and then the university keeps nothing but the grant money. This depends largely on the amount of financing. If the company finances a project 100%, I am able to agree to such conditions.
As a result, some of our thesis projects and dissertations fall under the Secrecy Act. We take such limitations in our stride here in Leoben, since the profit secures more jobs for additional lecturers, resulting in growth, outstanding knowledge, and the ability to sell ideas worldwide. However, would it be a good idea and practical if all universities work so closely with industry?